I'm Danny.
I'm Tyler.
And I'm Connor.
And this is our MLB attendance data analysis.
This is our executive summary. The main question that we wanted to ask was what impacts attendance for a Major League Baseball game? And basically these were split into three different variables: the outdoor condition variables, venue variables, and then the team variables. We got all of our data from Kaggle, the 2015 to 2018 pitch data, and then we use the time series to forecast the average capacity.
Yeah, so then we tested for multicollinearity and ran multiple regressions for the variables at hand. And then we interpreted the data, came to conclusions, and then we're able to predict some future MLB attendance games based on our model.
So I'm Ashton,
And I'm Nikki.
and this project was of particular interest to us because we're a group of 3 baseball players and 2 softball players, so this had a lot of appeal to us. And we also noticed that there was variation in attendance between different games across the season.
Yeah, and there are 162 baseball games for each team in a season, and the best teams move on to the playoffs. And then playoff games are in a series of the best of 5 games for the first round, and then the best of 7 games for the remaining rounds. So now we're on to our question of interest, and our main question is what impacts attendance for a Major League Baseball game? And going off of our variables, we have: does weather condition determine attendance? Does the temperature outside impact a game's attendance? And does wind speed determine attendance?
So along with the different weather variables, we also have different variables within the actual fields themselves, such as who is the home team, who is the away team, and also the venue plays a big part in this because different venues have different hypes behind them, different legacies, and different capacities.
So given those questions, we came up with some assumptions, and our first assumption is that people don't want to go to a baseball game if it's windy or rainy outside, and they'd rather go to a baseball game and enjoy it more if it's sunny out.
And with the variables of like where the field's located at, we do think that people are much more likely to attend a game that's local with them than travel to one. Along with also different venues like are more fun to attend than others, or they're just more well built in nicer areas.
We got our data from the website Kaggle, and in the data set originally we had 9,500 rows, and we decreased it to 750 by a random sample, just so that we could kind of decrease the amount of outliers. And then the other variables that were included originally were things like umpires, final score, start time, and delay time. But for example, final score didn't really matter because tickets are already scanned at the beginning of the game, and it doesn't have any effect on the attendance. And we didn't use any of these just because we didn't think it would affect attendance. And then we picked the 6 independent variables that we thought would most likely have value in forecasting the attendance.
Okay, so the variables we picked were home team and away team. So each team that is playing, that will have an impact on the attendance because people will want to go see those teams being played. Venue, so wherever the game is being played, Colorado, Los Angeles, New York, they're really popular stadiums, so they'll attract more attendance. We have temperature, weather condition, and wind speed, which all factors into the outdoor conditions that affect,
The method we used was the multiple regression model, and this was basically used to find p-values that were above 0.05, and if they were insignificant, which means we'd get rid of them. And then a step from multiple regression model was the correlation matrix, which basically is used to determine if like any 2 variables were above 0.7, meaning they're too correlated.
In addition to the multiple regression model, we used a time series, and we used 2 forecasting methods. First one being the naive forecasting method, and the second one was a 2-month moving average. And our independent variable was attendance, and then we forecasted predictions for the venue.
So for our methodology, we ran a multiple regression model using Excel. We then had to determine if any of our variables had any multicollinearity, which means they are 2 correlated between each other. To do this, we ran a correlation matrix using Excel as well, and found that none of our variables were over 0.7, meaning that none of them were 2 correlated with each other. So we kind of lucked out.
And from these multiple regression models, we were able to determine if any of our variables had a p-value higher than our desired alpha of 0.05. We chose a 0.05 alpha because we wanted a 95% confidence interval to include 2 standard deviations of data from the mean. We ended up having to actually eliminate 3 variables from our hypothesis. This included if it was an away team playing, the weather condition, if that was like sunny, overcast, or raining, and then the wind speed. Here we have a list of all of our hypotheses, including all the different betas within a regression model, depending on the venue, the home, and the temperature. And the way these work is that if the null hypothesis and the variable being tested is equal to 0, then it's proven to not be significant.
Going a little bit more in depth into our time series, we used two forecasting methods. We used exponential smoothing and we used a 2-month moving average forecasting method, and we found that the mean squared error using the 2-month moving average was smaller for all of the venues, which means that it was a better method than compared to the exponential smoothing. So since we just talked about some methods that we did use, what are some methods that we didn't use?
We cannot use simple linear regression because that can only have one independent variable while we had multiple. And then the second method we cannot use was hypothesis testing because we had too many variables to take into account. And to come up with a conclusion for our business problem, the best method used was the multiple regression model.
So here we have our regression model for these variables of the MLB attendance. So beta 0 obviously is our intercept, and then beta 1 is the home team, which every single one of our variables had to do with the home team at one point. And the betas 2, 3, and 4 are the different venues that we chose, and then beta 5 is a temperature.
Yeah, so our intercept, which is 22,674, is our model's representation of an average of MLB attendance on any given day. Again, that's just our model. It might not be the exact average, but our model, that's what we predicted on that. And then the next coefficient is the home team. And as you can see, it's a bit low, but that's because it's not huge of a factor when predicting MLB attendance. But it's still more likely that people attend a home game, like a local game or anything, rather than away. So our next 2 through 4, we have the venue coefficient, which everything that factors into that, like venue appeal, team status, like how well the team is playing, and capacity of venue, because a lot of stadiums don't hold the same amount of seats. There's different capacities around the league. So you can see that in the Tropicana Field coefficient, it's negative because it's actually holds the lowest amount of seats in the MLB, and the Rays have known to be not that good in the past years. So they bring the model down. And then in our last coefficient, we have temperature, which shows that the hotter the weather is, the higher the predicted attendance will be in the end.
Moving on to the data. This was the first run that we used with all the variables. First we had to get rid of the weather, then wind, and then the away team just because the p-values were over 0.05.
And look at the second run of our data. The R-squared value is actually a little bit lower, and these were actually the original inputs that went into our regression model because none of the p-values are above 0.05.
These are the residual plots. As you can see, the venue dummy variables all look very similar because they were either a 0 or 1 depending on if they were played at the stadium or not.
So look at the weather variable. We had 0 through 9 to account for different types of weather conditions, whether that be sunny, cloudy, overcast, this and that. And then we decided that there were no adjustments needed because none of these had a U-shape or showed a quadratic function within them. And then windy and away were the very two clear graphs that there was really no relationship in them. Looks like the scatters were just put in there.
So when running our correlation matrix, we found that our model had no multicollinearity. And we find this by running all of the variables and then seeing if any of them had a 0.7 relationship or higher, and we found that we didn't have any.
Alright, so as you can see, our R-squared is extremely small at just over 12.5%. And as previously mentioned, we were working with over 9,500 rows of data, so we cut it to 750 random rows. And in our case, with having so much data, we learned that the outliers in the data, they skewed the regression immensely.
With that said, the main reason our R-squared was so low, we're predicting, was because the different venues hold a different amount of seats, which causes the outliers, like said, to throw off our model. The reason we chose Wrigley Field, Coors Field, and Tropicana Field was because they all have different features and stay pretty consistent with their average attendance.
So here we start predicting different attendances at our 3 venues across different days in our data. And the way that we found this was we took the temperature from the actual day and took it into our regression model. So our predicted value at April 12, 2016 in the Rays Stadium was 11,376, and the actual value was 10,283.
That was close, bro.
So this was actually a lot closer than we expected it to be, because with having a small R squared of 12%, it should have been a lot less accurate.
Our prediction for a home game at Coors Field on July 13th, 2018, on an 88-degree day was about 35,000 people, and our actual data for the home game was about 38,000 people.
Good prediction, bro.
This prediction was surprising because our R squared was 12%, and so our model should have been a lot off.
And our final prediction was at Wrigley Field on July 25th, 2018, on an 83-degree day. We had over 38,000 people there attending, and the actual prediction was about 35,500.
You over-predicted, bro.
And still, with an R squared of 12%, this was still a lot closer than it should have been.
So this is our conclusion for our regression model coefficients. We have it pasted at the top. Our 22,000 represents the average capacity of our MLB games. 132.463 is our coefficient because most people are more likely to attend their home field versus an away field. The negative 16,000 is what we use with the Tropicana field because its capacity is small and their team generally doesn't perform well. Our 6,000 is with our Coors Field because they have a fun field and they hit a lot of home runs. 9,000 when using Wrigley Field, it's nostalgic and it is a super popular field in a big city. Our 68 times the temperature is what we use because people enjoy baseball in warmer months versus colder months. After we conducted this, we found that the home team, the venue, and the temperature were significant in determining our attendance, and these variables directly impact a person's desire to attend an MLB baseball game. We came to conclude that the variables that did not impact our overall attendance were weather, wind, and the away team, and the variables that did impact were the home team, venue, and temperature. We believe our model would be more precise if we used the time of the day and day of the week. More people are able to attend games in the summer, after work, or on weekends. We also use the entire season for our regression model, including early season games and playoffs. And a lot of people go to playoff games, so there's higher attendance there versus other games. And we could have also taken into account the fact that each team in the MLB has a different capacity to their venue.